Right, so up to now we've learned how to create a straight line equation, and we've also learned how to create a circle equation. And so in this video we're going to be looking at when we have both of them together, and we're going to see if these two equations would intersect or if they won't intersect, and if they do intersect, where would they intersect. Okay, so there are certain situations, such as if I was to draw an example where we have a circle like this, there could be a situation where the graph or a straight line touches it just once. Okay, there could be another situation where it crosses like twice, like here, once, twice, and there could be one final situation where it doesn't even cross at all, so there's no intersection. Okay, so obviously we're going to try and find when this will be in each case, and also what the points will be. Right, so you'll see later when we're doing examples that what we're going to be looking at a lot of the time is the discriminant. Okay, so the discriminant was the BA minus 4AC value, and this in quadratics allowed us to show whether it had how many roots it had, right? So if it was bigger than 0, it'd be 2 roots. If it's less than 0, it'd be no roots. If it's equal to 0, it'd be 1 repeated root. So this can also be used when looking at intersections between circles and lines, because in this case, when there's the black line, there's no intersection point, right? Meaning there's actually going to be no root. So the b squared minus 4ac value will be less than 0. For the green one, there's going to be 2 intersection points, i.e. there's going to be 2 roots. So if you were to work out the discriminant, you'll find a value which is bigger than 0. And for when it crosses it just once, you see that it's 1 repeated root, so you find a value which is just equal to 0. So this is just another piece of information that we're going to be using just to solve these kinds of problems. Right, so let's start off with something simple first. So we have a line y is 2x minus 2, and it meets the circle at a and b. So in this case, it meets twice. So first they're asking us to find the coordinates of a and b. So this part is fairly simple because we can just plug it into each other and try and find a and b. So y is 2x minus 2. I'm going to plug that into the circle equation. So x minus 2 squared plus y, which is 2x minus 2 squared is equal to 20. Now just rearranging for x. So we get x squared minus 4x plus 4. We get plus 4x squared minus 16x plus 4 plus 16, sorry, is equal to 20 like this. Okay, and so I can rearrange. I get 5x squared minus 20x is actually equal to 0. So therefore I can factorize x minus 4 is equal to 0. So x is going to be 0 or 4. So these are going to be x positions for a and b. To find y, well, I can just plug it back into this y equation to find the y coordinates. So y, if x is 0, plugging it in will be minus 2. If x is 4, plugging it in will be 6. So these will be the coordinates of a and b. Right, in part b, they're asking us, show that AB is the diameter of the circle. So diameter means like it's twice the radius, right? So looking from here, the initial radius, or radius squared, is 20, right? So the radius would be the square root of 20, which is equal to 2 root 5. So therefore the diameter is going to be equal to 4 root 5. So we just need to show that AB, the length AB, is 4 root 5. And that we can do that by just finding the distance between A and B. So the distance will be changing x squared, so it's going to be 4 minus 0 squared, plus changing y squared, 6 minus minus 2 squared, leaving us with 4 squared plus 8 squared, which is 16 plus 64, which is root 80, which I can rewrite as 4 root 5, like this. So the distance between A and B is 4 root 5, and this diameter is 4 root 5, so we know that AB is the diameter of the circle. Right, let's try another more difficult question. So we have a line with the equation 4x minus 1, and it does not intersect the circle with the equation x squared plus 2x plus y squared is k. Find the range of possible values of k. So it does not intersect. So as we said earlier, if it does not intersect, what we're going to use is, even if we plug it in, we won't get a solution, right? So what we're going to be doing is looking at the discriminant. So let's plug it in first. So we have x squared plus 2x plus y is going to be 4x minus 1 squared is equal to k. Let's rearrange, expand and simplify a bit. So we get 16x squared minus 8x plus 1 is equal to k. We'll have 17x squared minus 6x plus 1 minus k is equal to 0. So this is going to be the quadratic equation. But because it does not intersect, we know there won't be any solutions to this, even if we were to use maybe the quadratic equation or to complete the square. So what we're going to do instead is look at the discriminant. So the discriminant was b squared minus 4ac. So this is a, this is b, and this whole term is going to be c. So we're going to have minus 6 squared minus 4 times a is 17 times c is 1 minus k. And because there's no solution, this has to be less than 0, so smaller than 0 like this. Now it's just a matter of just making k the subject. So we have 36 minus, this is 68 minus 68k is less than 0, just expanding it. We'll get minus 32 minus 68k is less than 0. So minus 32 is less than 68k, so k is going to be bigger than negative 2. So for whenever k is larger than negative 2, there will be no solutions, or there will be no intersection points between the line and the circle. So as you can see, we use the discriminant just to show, by the fact there's no roots, what the range of k would be.